What I'm going to require from you now is a little bit of imagination, but it's worth it because it will make trig really easy for you. Imagine the ground. Now, imagine a wall perpendicular to the ground. Now, imagine a plank, a wooden plank. It would look like this. The length of the plank would be r. The thickness of the plank would be negligible, so close to 0. And the depth of the plank, we don't really care because we are going to look at the plank from the side. Now imagine placing this plank at the corner here, attached to a mechanical system that allows you to move the plank or change its orientation like this, defining an angle theta like this. Right, now imagine light, a beam of light comes from the sky and all the beams are parallel. You see what happens? The plank is blocking some of the beams of light, and this results in a shadow. This shadow is the projection of the plank on the ground. It's like a little bit when you do these things with your fingers, you know, and you have to make some shapes using the shadow. You are projecting the shape of your hand on a screen. Here, the shape of the plank is projected on the ground and results in the shadow. What would be the length of the shadow? It will depend on the size of the plank. Yeah, if the plank is large, well, the shadow is large. It will also depend on its orientation. You see? If the angle here is large, well, the shadow will be not so long. But if the angle is small, the size of the shadow will be larger. If the angle is 0, the size of the shadow will actually be the length of the plank. The length of the shadow depends on two things. The length of the shadow depends on the length of the plank and the angle, the orientation of the plank. The length of the shadow is equal to the length of the plank multiplied by the cosine of the angle. Now, I have a little mnemotechnic way to remember. When I want a projection of the plank on the ground, I need to squash the angle. And this is what I'm doing. I'm squashing the angle. You see what I mean? I'm playing on words a little bit, but it's very practical. Because I suppose you guessed now that the plank is a vector. So I can represent the axis x and y and a vector r. Yes? And there's an angle theta there. Well, when I want to know the projection of r on x, giving me the x coordinate of r, I squash the angle in order to get this coordinate. So I get x of r equals r cos of theta. Imagine now that we have a beam of light that goes horizontally. So it hits the wall. But when it reaches the plank, it is blocked by the plank, leading to a shadow, this time on the wall. Let's call it length of the shadow on the wall. Well, the length of the shadow on the wall will also depend on the length of the plank and the angle. So the length of the shadow on the wall is equal to r multiplied by the cosine of the angle that I'm squashing. So here is a complementary angle of theta. It's 90 minus theta. But 90 minus theta is sine theta. Applied to our vector, the projection of r on the y-axis will therefore be r sine theta, and this is the y coordinate. Why is this really practical?